Hi everyone, my name's Sarah and I'm a design engineer at Rolls-Royce. Outside of work I'm with a team called the Bristol Gulls and we're 4 women who've set ourselves the challenge to row unaided across the Atlantic Ocean in December this year, and we're going to be making that crossing in the most sustainable way possible. In the team and in this video we've got myself, Lorna, Sofia and Leah, who's our project manager. And putting this video together is Chloe. She works in the television industry and she's also going to be rowing with us in the team. If you're interested in a bit of adventure and you like problem solving, hopefully this is going to be a good project for you amidst all of the disruption you must be having right now. Right, I'll give you a bit of background about the project. We're going to be rowing from the Canary Islands across the Atlantic Ocean and finishing off here in the Caribbean on the island of Antigua and Barbuda. That's a journey of 3,000 nautical miles. For our crossing, we're going to need electrical power. That's for things like our navigation equipment, the radio, the satellite phone, any lights that we've got on board, and the water maker needs power as well. So my question to you for this project is, how would you generate electrical power on our ocean rowing boat? At work I'm a designer, so I'm going to talk through the design aspects of this project that you need to think about. And the very first part in any design is gathering requirements. I've got 5 cardinal requirements for you, which you can write down. The first one is that whatever you come up with must fit on the boat. So these are dimensions again, 28 foot by 5.7 foot. And for anything else, if you're wanting to guess like surface area, just make a reasonable estimate. So for the cabin here, if you want the top, just make a guess of 2 meters by 1.5 meters, something like that. It's good to get into the habit of not knowing everything about the project at the start of the design. That's quite realistic in engineering, and to make educated kind of estimates before you find out more detail. The second requirement is that I want you to give us a minimum power of 220 watts at 12 volts. The third requirement is that it must provide power for at least 50 days. That's okay if you've come up with something rechargeable, you don't need to worry about that, but if it's not rechargeable, it needs to last at least 50 days. Our crossing is all about sustainability, so your design should be environmentally conscious. And the last requirement is that it should be lightweight, so every kilogram that's on that boat we need to propel forwards with kind of human power alone. So I'd like you to make it as light as possible, please. You've got your requirements. The next part is concept generation. So this is where you can be really creative, get online, have a look, see what's out there in terms of solar panels. You can think about wind power. It doesn't have to be something that's commercially available. It can be nuclear, you can look at dynamos, anything, like just go crazy in the concept generation phase. Then you need to start down selecting these concepts. So the first thing is to compare them against the requirements that I've given you, and you can cross off any ones that don't meet the majority of these requirements. And you're also scoring them for things like electrical efficiency, is it efficient? The power to weight, the robustness, how risky it is. Think about how you're going to mount it to the boat. Think about how hot it's going to get. So I showed you where we're going to be rowing there, and that's largely across the equator, so it's going to be in quite hot, quite an extreme environment. So think about that. Think about how easy it is to use, how easy it is to maintain, and how easy it is to manufacture. And I think that's a good point to hand over to Lorna, who's going to talk about manufacturing.
Hi, my name's Lorna. I'm one of the Bristol Gulls and I work as a manufacturing engineer at Rolls-Royce. At Rolls-Royce, I manufacture the composite compressor components that will fit into the Ultrafan engine. And these components that we're making are made out of composites, the idea being to make them lighter weight so that they help contribute to a more efficient engine design. So this is the manufacturing part of the task. Once you've thought about the design elements of your power generation solution, it's time to make some manufacturing decisions. So Sarah's already given you some requirements, particularly around sustainability and lightweighting. So this will obviously impact your material selection, but it's also worth considering if the materials you're thinking about are up to the task you're designing. So have a think about the mechanical requirements, electrical requirements, thermal requirements, general environmental operating requirements, so the fact it's going to be at sea a long time, flammability requirements, and material availability. You know, is it available? What are the restrictions around that? Next consideration is your manufacturing process selection. And this will be guided by decisions you make on the material choice, the size of your part, the volume of parts you want to make a year, the number of parts if you've got an assembly, tolerances that you're going to specify, surface finish, and this will all feed into the tooling that you need. So tooling that you're specifying will be fed by these requirements, and these include things like moulds and jigs, aids that will help make your part. So your aim specifically is to choose the ideal combination between material and manufacturing process that will minimise production costs but still produce a good part without compromising performance. Okay, now bonus points if you can demonstrate design for manufacture principles in your solution. So what is design for manufacture? This is the process of designing a product for ease of manufacturing. Okay, ultimately trying to make a better part, but by reducing costs where you can. And these are a series of simple checks that you can run through on your design and your process that just aim to simplify, optimise and refine the product design. Okay, so for example, some principles you could consider in your design are: can you minimise the part count? Can you use standard parts and materials where possible? Can you come up with efficient joining solutions that again minimise the number of parts and standard parts, number of processes? Where can you loosen tolerances? Tighter tolerances mean more money. So what can you get away with? And can you streamline the number of manufacturing operations, processes? Can you remove the need for secondary operations? This is a little bit extra, but remember your goal, which I'll go through again, which is to choose the ideal combination between material and manufacturing process that will minimise production costs and still produce a good part without compromising performance. Good luck.
I'm Sofia, I am part of the Bristol Gulls, and I am an economist and a chartered accountant. So I'm bringing you this section of the task in maths and economics. And my question to you is, how is the current market disruption impacting the concept you've selected for our boat? So you have been looking into power, you have been looking into manufacturing, and now I'm asking you to consider certain dynamics happening in the market that are going to impact in different ways this concept that you have selected for our boat. So in order for you to do this, I'd like you to consider the following things. What are oil prices doing? How is coronavirus impacting the financial crisis we're in, energy and industrial commodities such as uranium and lithium, and any others you can think of. And I'd like you to think of the impact that this will have in such concepts, such as supply and demand for certain resources that we will need, inflation and or deflation, exchange rates, prices of raw materials, and international trade and travel. And now any other considerations that you may have that you think will impact the concept that we've selected for our boat. I hope you find this interesting. It is certainly a very interesting dynamic we're in at the moment, and the markets are doing some funny things, so it will be really interesting to see what you come up with, and how you actually see from a bigger picture to the detail of each of these elements, how you think is going to impact our journey, and how you think is going to impact the concept of the vessel and how it's powered and how it's manufactured. So any questions, just reach out.
My name is Leah and I'm a Technology Programme Manager at the National Composite Centre in Bristol. I'm supporting the Bristol Gulls as their project manager to ensure that they get to the start line of their incredible race in the smoothest and most prepared way possible. Sarah, Lorna and Sofia have told you what they want you to do. Now you need to have a think about how you make sure your project has the greatest chance of success. So how do we measure the success of a project? Generally in the world of engineering, it comes down to three things. So did you deliver what you were asked for within the time frame set? So time. Did you deliver what you were asked for within a budget set? So cost. And did you deliver to the level of quality that your customer is expecting? So quality, time, cost, and quality. In the context of this project, your customer is the Bristol Gulls. They've already started to define some of the requirements for the generator, and you now need to determine how you're going to measure the success in meeting their requirements. So how are you going to do this? So as a project manager, we often use acceptance criteria documents as a way of capturing our customer requirements and agreeing a scope of work. You can then revisit this document at the end of your project to understand whether you've met all of the criteria that you agreed with your customer at the beginning of the project. Therefore, your first task is to create your acceptance criteria list for the generator design project. On the screen now is a really useful method to help you create your list and prioritise your customer's requirements. It's called the Moscow method, and it allows you to state whether a product must, should, could or won't have certain characteristics. Once you understand the scope of what your design is, you need to have a think about how you're going to plan your activities to ensure that you deliver them on time. Therefore, your second activity should be to create yourself a project plan which breaks down your work into smaller tasks. This should take the format of a Gantt chart, an example of which is now on the screen. This will list out your activities and your planned timescales for completing each task. Once you've created your project plan, do try to make sure you keep on reviewing it to keep yourself motivated and keep yourself on track and understand what dates you're working to. With your acceptance criteria and your plan finalised, you're ready to start designing your generator. Good luck!
You've heard from everyone in the team now, so just a word from me to say hope you have good fun with this and good luck.